We will now use the trick we developed in graph 8.3 to identify situations where a decrease in the tax will cause an increase in the tax revenue from a worker, and situations where a decrease in the tax will cause a decrease in tax revenue from a worker. Again, we assume that you have 60 hours of leisure per week available to you, and we begin by drawing the before-tax budget constraint. An introduction of a wage tax is then equivalent to a decrease in your take-home pay. As a result, the budget constraint rotates inward through bundle E. We introduce here two different wage taxes, a magenta 20% wage tax and a green 40% wage tax. In order to identify how much in the tax you actually pay, we have to know where you actually consume on the after-tax budget constraints. Suppose then that you consume at bundle A on the magenta budget constraint if you face a 20% wage tax. Using our trick from graph 8.3, we can then indicate the actual tax payment that you make as the vertical difference between the bundle A on the magenta budget constraint and the lowercase bundle a on the blue budget constraint that lies directly above capital A. We can then do the exact same thing to determine the tax payment the worker would make under the 40% tax. We begin by identifying the worker's optimal bundle A prime on the green budget constraint because that's what he'll actually do if he faces the 40% tax. We then use the trick to draw the vertical distance between bundle A prime on the green budget constraint and the blue no tax budget. That's the tax payment the worker will make if a 40% tax is imposed. Notice that the tax payment under the 40% tax is bigger here than the tax payment under the 20% tax. Thus, cutting taxes from 40% to 20% would lead to a decrease in tax revenues from this particular worker. In panel B, we'll illustrate the opposite case, a case where cutting taxes will actually lead to an increase in tax revenues from a worker. We again begin by illustrating the three budgets, the blue without tax budget, the magenta 20% tax budget, and the green 40% tax budget. By finding the optimal bundle A on the magenta budget, we can then use the trick to indicate the size of the tax payment that this worker will make under a 20% tax, just as we did in panel A. Now, if a cut in taxes from 40% to 20% actually leads to an increase in tax revenues, then it must be that the tax payment the worker makes on the green budget constraint is smaller than the tax payment we just identified on the magenta budget constraint. This will require us to have an optimal bundle on the green budget constraint that is much farther to the right, and so we indicate a relatively flat indifference curve that is tangent closer to bundle E, or the endowment bundle. We use the same trick again to indicate the tax payment on the green budget constraint as a vertical distance between the optimal bundle A prime on the green budget constraint and the blue budget. The farther this optimal bundle A prime on the green budget lies towards the endowment bundle on the horizontal axis, the smaller this vertical distance between the green and the blue budget constraints gets. Thus, the more that the worker reacts to an increase in the tax by cutting his work hours and increasing his leisure hours, the more likely it is that an increase in the tax will lead to a decrease in tax revenues, and thus a decrease in the tax will lead to an increase in tax revenues. Here we have in fact shown a case where the vertical distance under the green budget is smaller than the vertical distance under the magenta budget, and so a decrease in the tax leads to a slight increase in tax revenues. A cut in the wage tax is like an increase in the wage, and we know from our previous work that when our wage increases, there are offsetting substitution and wealth effects assuming that leisure is a normal good. An increase in the wage causes a substitution effect that tells us to work more, and a wealth effect that tells us to work less. Thus, when the wage tax is cut, the substitution effect tells us to work more, which plays towards the argument that the tax cut might actually cause an increase in revenues because I end up working more. The wealth effect, on the other hand, tells us to work less as the wage tax is cut, undermining the argument that a decrease in the wage tax will cause an increase in my tax payment because I end up working more. In order for my tax payment to increase as a result of a decrease in the wage tax, the substitution effect, therefore, has to be sufficiently much larger than the wealth effect to not only outweigh it, but outweigh it enough to actually cause my tax payment to go up at a lower tax rate.